Hi there, because holidays are coming, if you like it or not. Today, a quick look at this Lotus 5-meter string of LEDs, multicolor LEDs, but I don't have any batteries for it.
Ma, can I see your remote for a minute? Look, Ma, you can still set your alarm later, okay?
Oh, yeah, I have batteries now, so let's try this out. It takes three AA cells, and it's rather bright. As you can see, it works quite well. And what's weird about it, because three AA's is for the half volts, and it does say that it takes 3 volts at 15 milliamps. Let's dig into this. Firstly, I will get to removing the flap over the resistor, because they're simply dropping the voltage on this resistor, limiting the current. What I'm wanting to do here is convert this to USB using this lead that was broken off. I also have matching shrink wrap, and also I can tell you a little bit about this cable, because I disassembled it. It didn't work on my phone, so I started disassembling it. As you can see, it's supposed to be USB-C, but it actually has 4 pins, and they are not exactly, in the right places, so it couldn't work. Yeah, so it will do greatly as a cable for this little string. Yeah, that's about 450 milliamps. And let me quickly switch to the voltage range and see what's the voltage of the circuit at the output. So that will be, let's see, over here, 4.47. But if there is any load, yeah, that drops, because I think this battery isn't in great shape. And if I take a look over at the voltage that is dropped on the resistor itself, 0.8. So I guess they were thinking about 500 milli. So I will try to keep that with the USB power supply, power supply. So that would make it perfect. But the problem I have is the resistor, and I think this is half watt, and it couldn't maintain, because it's almost 2 ohms. If I take a look, so it will show me a wrong value over here, but it should be around, yeah, should be around 1.8, but it won't show me a correct value on the reading, because it's the too low resistance basically. According to the colors, it's 1.8, so this is close enough. I guess the problem would be also resistance of the leads, so it's showing that too. So this is the resistor. I guess it's too small to use it on the USB power supply, because that would be a much higher current going through the circuit. So let me find out what can I do about this. So considering full battery capacity, it's 1.5 volt drop on the resistor and 1.8 ohms. That would mean over 800 milliamps. So that's quite a lot for this. I don't think that's really great, especially considering that 1.5 times 0.833, that would give it, this is, I think, half watt resistor, and it dissipates 1.2 watts. Not really that great. It will overheat quickly. I don't think that's for long use, especially considering that those batteries should run you 3 hours if they were new, tops. Obviously the voltage would drop over time, but Okay, so let me try and find out what value would be best for 2 volts, 2 volts divided by 0.5, because that would be the current. So the base value would be 4 ohms. And if I connect at least, I guess if I connect 4 quarter watt resistors, that would dissipate 1 watt in total. 1 ohm resistors end to end, 0.5, that's a 1 watt dissipation. That's a far better idea. Let me try that. I don't have any quarter watt resistors at the moment, so I will go with those. And I also will reuse this one. So this is, let me try that in, because we will have a power supply. Come on guys, power supply over here. So let's call this a battery, 5 volts and something like that. Oh yeah, and the LEDs over here, but in a second. So I will reuse this little resistor, and that will be 1.8 ohm, and those 2 little ones, but they are a quarter watt, but at 1 ohm. And here we have it. And let's call this LED. Let's just show just a single one. What do we have here? Exactly. All those 3 are in series. And this is 0.5 watt. Those 2 are 0.25 and 0.25 watt. I went with this one just because I have it at hand. And in total, that would mean 3.8 ohm at 1 watt. So here it is. They will basically dissipate something around, because the drop over here will be 2 volts, and they will dissipate because it's not full 4 ohms. They should dissipate around 1.1 watt or maybe a little less, or 1.01, something like this. They should be fine, especially since this one was overrun twice the wattage it has. So yeah, that should be perfectly fine. The wattage in series basically adds, because between this and this, if I will measure the volt, let's show this like so on the schematic. This is let's call it this 2 ohms. For simplicity's sake, this should be about half volts at the 2 volts drop. So if you consider this, that would be half volt at 1 ohm. So the current through this part would be half amp, and half times half is basically a quarter. So it will be perfect if that would be actually 2 ohms. It probably is almost like that. Should be alright. So let me solder this up, and let's see how it works. So let me cut over here. I will figure out later on. I won't be throwing this out yet. I have to solder this. Okay. So these are the resistors. Let's cut this one. I will figure out which is plus, which is minus later. Shouldn't be difficult. This insulation is really thick, but it's often the case that the cable thickness is fine, but they made the insulation thick so they don't have to put a lot of copper inside the cable. So yeah, because plastic is far more cheaply available than any kind of copper. I hope this wire would be fine. Yeah, let me just, because it's really gummy, this insulation, kind of weird. Let me connect the power bank and quickly check the cables and polarity and so on. I'm hoping for the red and black wire, plus and minus, but you never know with those cables. Yeah, that was a good guess. So yeah, so black is minus. Let's cut the remaining ones over here, because I won't be needing them. So firstly, if I trim those, because I want to, you know, the shorter the length of this, the shorter the thickness will be in the wire to connect those. I connected the red one to the 1.8 ohm, and now I'll connect those two to the black wire, so I can use the shrink wrap afterwards. And now the important part is that those won't touch each other, so it should be like this. I thin those wires, and let's quickly check with a power bank if the circuit works now. Yeah, as you can see, because obviously it will be far better when I solder this, because it doesn't make a proper connection right now. Let's just do this. I marked the minus with the black marker. Let me solder this over here. And remember, don't forget the heat shrink, because that will simply mean that it will have solder everything. And yeah, I have it over here, just ready. Let me see. Yeah, that shouldn't cause a short circuit. Let me complete this, and maybe if I will simply bend it this way. Okay, here we are. Alright, let's cover this in the heat shrink by putting this over the resistor without hopefully shorting everything out. Yeah, like so, just delicately, because yeah, you basically don't want to see any of those cables hanging around in the resistor and so on. And let's check this out by connecting. Right, that should be pretty fine. Let me use my little torch to shrink wrap this. And here we have it. What my meter shows me, the little USB meter, it shows that it uses 300, almost 400 milli. I'm wondering if I use another USB power bank. Yeah, over 300, because what I suspect is going on here, they are pretty hot. What I suspect is going on here, that the cable is a bit thin, and it also limits the current. They would be running just fine, those LEDs. They won't be using too much of a current, and also the resistor here won't be overrun too, so that should be fairly fine, especially for some reason 4 something volts. That's not a lot from this power bank. Maybe it's not properly charged, but at 5 volts it should be about 400 tops. Let me try this again with this one. Yeah, not really great, but 400 milliamps, so that's pretty fine. Let me unravel this and see how it looks. I wrapped it around my false window from another video, and as you can see, it's amply bright. It's basically the same in person. I corrected the brightness settings on the camera, so it would look a lot closer to the reality, and for 400 milliamps it's running on right now. It's perfectly fine. It's a really nice holiday feel of the lights, and the colors are really bright. The phosphor added to the LEDs changed the colors on them, but I'm not exactly sure what's the technology there. So that's it, guys. That's converting the battery lights to the USB supply. Thanks for watching, and please subscribe.